In this video, we're going to extend our work with proportional tables and equations and take a look at what those relationships look like when represented graphically on the coordinate plane. Before we do that, we want to make sure that we have a pretty solid understanding of how the coordinate plane is set up and how the coordinate plane works. We create the coordinate plane by taking a horizontal number line and a vertical number line and crossing them. In doing so, we can give each location within the coordinate plane an address based on both an x and a y coordinate. Anytime we write that address, we're going to write it as what we call an ordered pair. The x coordinate next to the y coordinate, always in parentheses, always x comma y. The x-axis is always the horizontal axis. So the x coordinate tells us how we're moving horizontally around the coordinate plane. The y coordinate is the vertical coordinate because the y-axis tells us about vertical motion within the coordinate plane. Whenever we're looking to identify a point within the coordinate plane, we always start from the point in the middle where the axes intersect. This point is called the origin because it's where we start, it's where we originate from. The address or the ordered pair for the origin is 0, 0 because since I always start here, I'm not moving anything to the left or right, so that's 0 units, and I'm not moving anywhere up or down, also 0 units. If we look at B, we start from the origin, and first we start with our x-coordinate. We want to see how far side to side we have to move. Since we have to move to the right to get from the origin to B, we know that our x-coordinate is going to be positive, because the positive values are on the right side of the number line. If we are moving to the left, our x-coordinate will be negative, because we can see the negative values on the left side of the number line. To get to B, we count 1, 2, 3, 4 steps to the right. So my x-coordinate is 4. Once I've moved those 4 steps to the right, I have to look to see whether I need to go up or down to get to B. If I'm moving up, that's going to be a positive y-coordinate because we can see that we have positive numbers on the upper half of the y-axis. If we need to move down, that's going to be a negative coordinate because we can see the negative numbers on the bottom half of the y-axis. So I've come 4 units to the right, and now to get to B, I need to move 1, 2 units up. So my y-coordinate is going to be 2. Let's try another point. In order to get to C from the origin, I first need to move 2 units to the left. Because I'm moving to the left, this is going to be a negative 2 coordinate. Once I move 2 units to the left, I count 1, 2, 3, 4, 5 units up, and since I'm moving up, that's positive, so it's going to be positive 5. Next, we'll try D. Again, we start back at the origin. We're always going to start at this point in the center. To get to D, now I have to move left, and since I have negative numbers on the left side of my number line, my x-coordinate is going to be negative. So I move left 1, 2, 3, 4 units. Then I go down 1, 2, 3. So I'm at negative 3 for my y-coordinate. Go ahead and pause the video and see if you can identify the ordered pair or the coordinates for the point labeled with an E. Alright, so again, we start at the origin. To get to E, we have to move to the right 1 unit. So my x-coordinate is going to be a positive 1. Oh, I lost, there we go. Then once we've moved right 1 unit, we have to go down 1, 2 units. Since I'm going down, my y-coordinate is going to be negative, and since we move 2 units down, it's going to be negative 2. So there's the ordered pair 1, negative 2 for E. So now we're going to take what we know about a proportional equation and combine it with our knowledge of the coordinate plane. Our equation from last time was y equals mx or y equals kx. We used k before, we're going to use m this time. M represents our slope. Remember, before it was our unit rate. Here we're going to think about it as our rise over our run. Remember that y is our up and down. So when we talk about rising, we talk about moving up or down. Our run is our side to side. When you go for a run, you don't run up into the air or down into the ground, you're running side to side along the ground. So that's our change in x. This is the same thing as that y over x that we looked at last time in the proportional tables. This number, when applied in a graph, tells us about the steepness of a line. When we talk about steepness, we want to think about something like a mountain. If you're walking up a mountain that's really steep, it's really hard to go up. Whereas if you're walking along a relatively flat hill or a flat road, you're not really putting in a lot of effort to move. So when we want to find the steepness of a line, we start by looking for 2 points on the graph where we can easily identify the coordinates. So we're going to look for points on the graph that go through points where our grid intersects. We're going to look for corners on the graph paper. But we don't want just any corner on the graph paper. We want corners where the line goes through. So if I start with this point here and this point, I'm going to start with my rise. So I'm going to go up however far it takes me to get to the next point. So if I'm going from this point to this one, I'm going up 2 units. So my rise is 2. Then I'm going to run over until I hit the next point. So we've come up 2 and over 1. Then we do the division or reduce the fraction. We're usually going to leave this as a fraction instead of a decimal. And 2 over 1 is just equal to 2. So I take my equation, y equals m or kx, and here that value is 2. So my equation is y equals 2x. I can use other points on the graph. It doesn't matter which points I use, the answer is still going to be the same. So say I picked this point again, but now I used this point. Our rise would be 1, 2, 3, 4 units up, and 1, 2 units over. So we would do 4 over 2, which reduces to 2, the same thing that we got earlier. If I pick a different pair of points, I'm still going to get the same thing. If I go from this point here to my next point, we come up 4 over 2, we still get 2. So it doesn't matter which 2 points I pick. As long as I pick 2 points that are on the line, I'll be able to calculate that slope. Pause the video and see if you can find the slope for the second graph here on the right. Alright, so again, I'm going to pick any 2 points. I could even pick the origin here if I want. This is the point 0, 0. I come up 1, 2, 3 units. So my rise is 3. And then I run 1 unit. So my run is 1. 3 over 1 is the same thing as 3. So my equation is going to be y equals 3x. I take that answer and substitute it in. So now we're just going to practice finding the slope and that equation. It's the same thing each time. We're looking for our rise and our run. So I might even write that down at the beginning as I'm learning it, just so I remember what I'm doing each time. That way I can just identify my rise and my run, and I know exactly where they have to go. If I look at this graph, say I want to use this point and this point here. I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8. So I've risen up 8. And now I'm going to run 1, 2 units over. So my slope is 8, not over 8, over 2. We divide that and we get 4. So my equation is y equals 4x. When we have the 4 and the x next to each other, they're multiplying. So I can take any point on this graph and take this point, 1, 4. And my y coordinate is 4, and that's equal to the 4 from my equation times my x coordinate, which is 1. So 4 equals 4. If we check that and it doesn't work out, we know that something's wrong. So now let's try the next one. Again, I can pick any 2 points. Say I've got this one and that one. I'm going to rise up 1, 2, 3 units. So I have a rise of 3 and a run of 1, 2, 3. Any number divided by that same number is equal to 1. So in this case, my slope is equal to 1. So I could have y equals 1x, but when the coefficient or the number next to a variable is 1, we don't have to write it. So we can actually just say that this is y equals x, and that's going to be the final equation. So anytime we don't see a number listed next to x there, that means our slope is equal to 1. Go ahead and pause the video and see if you can find the last equation on your own. Alright, so for this one, we're going to do the same thing. We're going to pick 2 points, and pick this one and this one. We're going to do our rise. We come up 1, and then we'll run 1, 2, 3. So my slope here is equal to 1 over 3, or 1/3. Because we want to be able to see that rise and that run, I'm not going to turn this into a decimal. I'm just going to leave it as the fraction 1/3 and put that into my equation. So now that we know how to find the slope from a graph, we can very easily link together both the graphs, the tables, and the equations for our proportional relationships.